Hello everyone, welcome to our today's webinar. My name is Andrew and I will be your speaker today. I hope all of you are safe and staying home because safety matters the most these days. It is also a good chance to learn something new and that's what we are going to do today. It is my pleasure to show you how you can make data analytics and notifications work with the KaaIoT platform and how you can use them to create end-to-end IoT applications. Kaa is an open Internet of Things platform that has you covered when you want to integrate your favorite tools for data storage and analytics. In this webinar, we will explore data analytics with Kaa and the Elasticstack. That's a popular open source solution that comprises several components and offers great freedom for developers. From our experience, it is one of the best on the market, and so it was the most practical thing for us to integrate and use it with Kaa. A part of Elasticstack is Kibana, which we will use today for the data visualization. Elasticstack also includes Elasticsearch, Beats, and Logstash. During the webinar, we will look closely into Elasticstack and Kibana capabilities, then demonstrate you how you can access and use it with the Kaa platform, and finally we will run a simple application that sends Slack notifications upon a predefined event in the device telemetry. For those of you who are new to Kaa, let me start with a short introduction. All the features in Kaa are implemented with portable microservices, and Kaa as a whole is based on a flexible microservice architecture. This means that you can separately customize each Kaa feature, add new ones, or replace any existing ones with some third-party tools. Out of the box, Kaa provides all the IoT features you may need for a typical IoT application, from data collection to device management and IoT dashboards. You can also take advantage of open APIs to integrate Kaa features with your own modules and applications. That's how we actually integrated Kaa with the Elasticstack. Just in case you have not heard about the Elasticstack before, let me walk you through a few quick slides. After that, we will take a look at the demo. This diagram illustrates the integration between Kaa and the Elasticstack. First, you use Kaa to connect and manage your devices in the cloud. Then you use Kibana to visualize your device telemetry and set up integrations with a variety of apps, popular messengers, emails, etc. The user interface of Kibana is quite easy to learn and also allows for flexible configuration. Please note that Kibana integration is currently available only in self-hosted and KaaIoT hosted license plans. A free trial is available on our website. In a while, we are preparing to add this integration to the Kaa cloud as well. After you add a device to the Kaa platform, you can synchronize live and historical time series data with the Elasticstack. You can then query the device time series by specific parameters and telemetry types, restrict the value ranges in the chart, and get as detailed information on your device activity as you need. Kibana offers multiple data visualization widgets to show your data the way you like it most. It also makes convenient suggestions as to how you could display it differently. To enable collaboration, Kibana features flexible permission management that allows you to create various user roles, which could be something as common as admin and user, or roles with more specific permissions. We have also integrated the Elasticstack with the OAuth 2 server used in Kaa for seamless user management. Now, before we go to the demo, let me introduce you to Canon and Barbie, our mollyfish. It's no easy time for these fellas. While we are away working from home due to COVID-19, there is no one to keep an eye on them and their aquarium at the office. But how do we know if there is power outage? How can we be sure that their water filler and the other life support systems work with no interruption? We couldn't just leave the lives of Ken and Barbie to chance. So, we came up with a simple yet effective solution by using a smart socket on Kaa. You can see the solution diagram here. In case the electricity in the socket goes off, we get an alert to our corporate Slack account and have enough time to get to the office and save our fish. Simple, but potentially life-saving for Ken and Barbie. We have some dashboards to track the socket's live data in Kaa, and I will also show you how we set up an alert by using Kibana. Of course, a smart socket may have many other helpful applications, for example, when you want to remotely control devices without built-in connectivity. You can also use it to track the consumed power or, for example, set up a timer. We hope you'll figure out some useful applications for yourself. All the instructions on how we integrated this socket with Ka will be published on our website soon after the webinar. Now let's get started with the demo. Let me switch to our demo environment here. So we have already prepared the solution in Ka and connected the smart socket from a popular vendor to the platform. Let's click on this solution. As you can see, the home page here shows the smart socket real-time telemetry. We have 3 parameters here, that's voltage, current, and power. You can also use a control switch to remotely turn your socket on and off. I'm not going to do this to Canon Barbie, but we also have a small simulator set up here. You can see that this data is a little more artificial than the real one. But here I can actually toggle power on and off without compromising the safety of our fish. You can see that the power is apparently off, and probably we've got to do something. We also want the system to notify us of the outage. Well, in many cases when you need telemetry and device monitoring, you can have it all here. But to enable actual data analytics and alert management, we use integration with the Elasticstack. Let me switch the power back on here and let's go and check out the analytics. Okay, so here we are at the Kibana homepage. You can see here data coming into Elasticsearch. It actually comes from both of our devices every few seconds. If I click here, I can see more details such as the endpoint ID, voltage, timestamp, and so on. Well, to make this table a little more readable, I can select which fields to display. Like, let's say we add an endpoint ID, we add voltage, current, and apparent power. Okay. We can also do search and filtering here. I have prepared a few data searches. Let me open and show them for you. So let's go to the... let me actually show you what's inside of that filter. So we have a few filters in this search. That's Aquarium data. Let me edit it here. So Aquarium is coming from one of our devices, and this is the endpoint ID for that device. We can also do some additional filtering here, like for example 230 volts. If I added this filter, so this shows you the messages where the voltage was apparently higher than 230 volts. Let me enable this and see if that actually happens. Well, you see that this stuff actually does happen. So we have moments when the voltage exceeds 230 volts. All right, so that was a crash course on data exploration, search, and filtering. There are more capabilities here, such as custom visualizations. Let me open the voltage diagram. Well, that's what it shows, like some thresholds and the data grouping. You can also build your dashboards using the visualizations that you configured in Kibana. Like for example this one. Okay, it's coming up. So yeah, there is stable view, and then there is a histogram that I just showed you previously. Well, but the reason we came here in the first place is to set up automatic notifications. So let's go there. Generally speaking, notifications are useful when you want to be notified, well, immediately if particular changes happen to your device operation. In our simple case, I'd like to know if there is a power outage and my smart socket gets turned off. So in this alerts dashboard, you can see some of our previously created alerts. Let's take a look at the monitors and triggers that generated them. You can see here that we have a couple of monitors already set up. They watch the actual aquarium state and raise alerts in our corporate Slack. There are two things we want to monitor. The first one is the low reported power consumption. For whatever reason, that probably means that the aquarium systems do not perform as expected, and this is what the aquarium power monitor keeps an eye on. But also the power can go down for the entire building, and we would completely lose telemetry. And therefore we have this other monitor, Aquarium Telemetry, here. Let me show you how both monitors are set up. So this is the Aquarium power monitor. It's currently green. Let me show you the config here. So you can see that we defined it using the visual graph. That's probably the simplest way of defining monitors. It uses all the data indexes that we have in there using a wildcard. The timestamp field is just a timestamp. And what it does here is it queries apparent power reported by the device over all documents in the last minute, and the endpoint ID filters the Aquarium device for us. So essentially it averages out the power reported over the last minute. And that's something that is being done every minute here. Okay, so these are the numbers that we are getting, and these are 6.6 roughly volt amperes, and this is the normal operation power that we observe with our aquarium. Now let me go back here. So that was the actual monitor, but we also have a trigger, and this trigger actually keeps an eye on the reported power. And you can see here, well, the trigger name is Aquarium out of power, severity level is 1. That's not important, you can choose whatever you like. But the trigger condition is below 1. So whenever the reported average power over the last minute drops below 1 volt ampere, this trigger fires up. So this is where you can see this visually represented. These are our current readings, and the red line is the line below which we will get an alert. Now the actions, there is only one action configured here, and that's notify KaaIoT Slack, and it uses a destination. I'll walk you through destinations a little later. So it uses one of the two destinations we've set up for today, and this one actually sends messages to KaaIoT Slack. The subject here is the aquarium is out of power. The message is please investigate the issue ASAP. I'm sorry. The last but not the least here is the action throttling. So you can see here that we limit the amount of messages to 1 per 10 minutes because we don't want to be notified every minute. It's well, it's important, but probably not useful to be notified every 1 minute. Alright, so that's the trigger for the aquarium power, and again, as we saw, it keeps an eye on the average reported power over the last minute for our aquarium smart socket. The next monitor was for monitoring the actual telemetry that it actually keeps coming into the platform. It's somewhat similar to the previous monitor. Let me show you the configuration here. So the configuration is very similar, except it does not average any numbers, any sensor readings from the device, but it actually just calculates the count of messages received in the last minute from this endpoint ID. So this is our device. So we are calculating how many messages we received from that device over the last minute. And, well, obviously the trigger will look at the absence of these messages. So the monitor is scheduled to execute every 1 minute as well. And if we go back here to the trigger, so we have a trigger called no telemetry from Aquarium. And if I added this trigger, so you can see here that the trigger condition is exactly 0. So if we are getting exactly 0 messages over a minute, this trigger fires up, and we have an action here, and that action also sends a message to our corporate Slack saying Aquarium telemetry is lost, investigate the issue, and also we throttle the amount of messages to once per 10 minutes. All right, so we've looked at how the monitors are actually set up for our real production system. But now let's get our hands dirty and configure a new monitor for the simulator and then test it. Let's create a new monitor. Let's call it simulator power. So we will be monitoring the power reported by our simulator. Let's define it also using the visual graph. So the indexes will be any Ka reported data. The time field is also the timestamp, and again we are building a monitor to keep an eye on the reported power. So we want to calculate the average of the field called apparent power for all documents in the last 1 minute. Let's set it up exactly the same way as the previous monitor, and we will filter by our simulation device. Endpoint ID is, and let me go here, so I'm looking at the simulator. This is the endpoint ID for that simulator. Let me copy this and paste here. Okay. All right, so we are getting the average of apparent power equal to 6 over the last few minutes. And this seems to be, oh, it's not it. Yeah, this seems to be accurate. So this is the power that our simulator is actually reporting. We will schedule the monitor to run every 1 minute. Let's create this. So now we have a monitor, and the remaining thing is to create a trigger and create and define an action. So let's call our trigger low power. Low power. Severity level, let's leave it as 1. Trigger condition, let's make it below 1. So we are getting reports at around 6, so whenever we will get report of power under 1 volt ampere, that will be a condition for a trigger. Now the action that we want to enable here is to notify demo Slack. Let's select a destination. So as I said, there are 2 destinations that we have here. We've set up a separate demo Slack account, and I will use that for demonstration. Let's use as subject simulator is out of power, like this. Let's also define a message. This is a drill. We don't want this. Okay, so this is how the message is supposed to look like. And let's finally enable the action throttling every 10 minutes. Should be good enough. All right, we should be ready to create. Well, nice. So we can see that the trigger was successfully created and also activated. Let's now take a look at how it actually works. So this is our monitor. And let me go back to my simulator and simulate an outage. Let's power off the simulator. So you can see here that the reported current and the power is now set to 0. The data starts rolling into Elasticstack, and Kibana starts monitoring it. Now, while we are waiting, because the monitors actually trigger every 1 minute, and we have to wait a little bit for the monitor to trigger and understand that there is something going on. While we wait, let's go back here and I'll show you the destinations that we have set up. So, like I previously mentioned, we have 2 destinations here. That's KaaIoT Slack and demo Slack. let me show you the configuration for the demo Slack. It's actually extremely simple. You can see here the name. It's a Slack type destination, and the only configuration that you actually have to set here is the webhook URL. The way to get this is, oh, we actually have a message already here. But let me quickly show you how to get this. So when you go to your Slack account, you can search for webhook. You want to use an incoming webhook. You add this application. Let's add it to Slack. Alright, and this is actually very simple. Just choose the channel you want to post the message to and add it to your Slack account. This will give you the webhook URL that you want to paste in here, and that's pretty much it. You're done. Alright, so as I already mentioned, we actually already got a message here. So you can see this is the latest message. We just configured it, and this is from our Kibana that's monitoring the simulator. Let me toggle this back on to bring it back online. And actually, if we go here to Kibana, there is something else to take a look at. Let's go back to monitors and see our simulator power monitor. You can see here in the history of the low power trigger that it actually entered the alert state. That's red. So that's another way to see that something is actually going on. Cool. So let us now review what we have done today. We looked at the smart socket and also the simulator dashboards configured in the KaaWeb dashboard. We reviewed the integration with Kibana, explored a bit of its data search, visualization capabilities, and finally we reviewed a couple of useful monitors. We set up one more and we tested it. Quick and easy. As you can see, the whole process is very straightforward and doesn't take a lot of time. Well, that will be it for the live demo today. Before I go to your questions, let me quickly introduce you to our free trial plans for Kaa. There are two options basically, which we call the Kaa Cloud and a private hosted instance. The Kaa Cloud is a ready-to-go platform as a service that is accessible via a classic shared environment for all the users. It's already configured and you can start with it right away. It allows you to use up to 5 devices for free with no time limits. For more devices, we have paid plans. The second option, which is a private hosted instance, is a more personalized trial where we set up and host a dedicated environment and allow you to use as many devices there as you need. This option also comes with more personalized assistance and includes our latest features, among which analytics and notifications that I've shown to you today. However, this trial is limited to 30 days. After that time, you may continue using your dedicated environment by subscribing to one of our paid plans as per the number of your connected devices. This trial option is also perfect for enterprise-grade assessment of the Kaa capabilities. In detail, information on pricing, options like white labeling, and paid plan calculator will be soon available on our website, kaaproject.org. Alright, now I'm ready to answer your questions. Please give me a moment to look at those you already submitted, and please feel free to ask more now.